Alright, geometrical tolerance, desk reference, creating, interpreting ISO standard technical drawings. Geometrical tolerance, desk reference, creating, interpreting ISO standards technical drawings, Paul Green. Table of contents, chapter introduction, published summary, what is geometrical tolerance, when to use geometrical tolerance, orthographic representation, important, chapter 2, how to use this work, published summary, if you're creating technical drawings, step 1 through 6. B, if you're reading technical drawings, step 1 through 7. Chapter 3, single features, publishing summary, combination single features. Chapter 4, symbols, published summary. Chapter 5, tolerance frame, publisher summary. Chapter 6, datum, symbol, publisher summary, location, datum triangle. Chapter 7, datum target, published summary, 3-plane datum system. Chapter 8, tolerance featured, published summary. Chapter 9, tolerance zone. Publisher zone, summary, tolerance zone, direction. Chapter 10, theoretical exact dimension, published summary. Chapter 11, projected tolerance zone, published summary. Chapter 12, maximum material condition, publisher summary. Example 1, maximum material principle apply to datum feature, maximum material condition at perfect form. Chapter 13, least material condition, publisher summary examples. Chapter 14, envelope and requirement, published summary. Chapter 15, free state condition, published summary. Chapter 16, screw threads, gears, splines, publisher summary. Chapter 7, principles of independency, publisher summary. Chapter 18, general tolerances, published summary, angular dimension. Chapter 19, geometrical tolerance, examples. Chapter 20, quick reference table. Chapter 21, visual index. Chapter 22, index. Alright, preface. General tolerance can be used to describe the language symbols placed within the technical drawings to adequately define the allowable variation of part geometry. Geometrical tolerance is of various forms, has been around for 50 years and known widely, even accepted throughout the manufacturing industry. The development become available tool essential for the high standard of the demand of today's remote modern high technical workplace. The scope of the geometrical tolerance spreads across the board and is a system that applies with equally control small geometry like electronic components right through the very large geometry used, for example, by the companies manufacturing aircraft components. An accurate, respected communication system kind of essential for ensuring that today's highly competitive global market successful endpoint can be assured, but giving greater confidence throughout the manufacturing industry. The current internationally accepted standard of geometrical tolerance, ISO 1101-2004, standard upon the book was based. Throughout many years employed as a mechanical engineering designer, I worked at various design drawing offices. During this time, I was unable to find geometrical tolerance reference that could use the daily desk reference for my work needs, thus providing me with motivation to create this book. A designed desk reference to fulfill the requirements of anybody to apply with the need to understand geometrical tolerance on technical drawings. This would include engineering designers, draftsmen, workshop inspection staff, as well as technical engineers and students. I think we skipped a page. Preface. Alright, introduction. Publisher summary. Geometrical tolerance can be described by the language symbol placed for the technical drawings adequately to define the allowable variation. Part geometry for the chapter provides categories engineering drawing practice for the general principle of dimensioning and tolerancing, and explains whether the geometrical tolerance is a maximum allowable variation form of the position of the feature. Say that the tolerance has been a certain amount of the control over the form and attitude of the better degree of the controls required with the geometrical tolerancing should be used. The chapter discusses orthographic representation, various two-dimensional technical drawings, two orthographical projection methods used internationally, or first angle projection, third angle projection, engineering drawing, practices. Technical drawing can be categorized in 3 sections. General principle is concerned with the technical drawing layout, scales, line types, text sections, projects, and how to show common features. 2. Dimensioning and size tolerance for the descriptive of the principle of dimension for the how to apply tolerance for the not geometrical tolerance for the technical drawings. Also cover the mechanical requirements and surface textures. Geometrical tolerance for the controlling of the form, location, orientation as features of axis, plane, surface, and whole, etc. This is done by applying principle of geometrical tolerance for the engineering drawings with the aid of geometrical symbols. This book is concerned with the geometrical tolerance only. What is geometrical tolerance? Geometrical tolerance is maximum allowable variation on form or position of a feature. The control by defining size and shape of the tolerance zone, the specified parts of the feature must be within the tolerance zone. When you use geometrical tolerance, size tolerance dimension, figure 1.3 has a certain amount of control over the form of the attitude, figure 1.4. For the best degree control required with the geometrical tolerance should be 1.5. Then it shows A is shown in the drawing, and it shows the dimension line, the dimension, the size tolerance, arrowhead, projection line, also called the extension line and dimension, figure 1.3. 1.4, limited form attitude, shows the, is shown in by the drawing, acceptable finished plate, showing the limited form of the. Yeah, I can barely read that, and it doesn't let you zoom in. Alright, 1.5 example geometrical tolerancing. Position of features also control with the geometrical tolerance. For the use of the geometrical tolerance can retrieve the manufacturing cost should only be used when necessary. Orthographic representation, technical drawings use exist in various two-dimensional views of the defined object is known for the orthogonal projection. 2 orthogonal projection methods are internationally at first angle projection, third angle projection. The third angle projection, figure 1.2, is used in the United States and Canada, while the first angle projection is used mainly out through Europe and the rest of the world. First and third angle projection have the equal status and are approved internationally. ISO standards, ISO 1101, 2004, all figure for the first angle of the projection for the dimension tolerance for the millimeters. This is based for the standard first angle of the projection throughout this book. Shows first angle projection. Look where the arrow position point of the object. Draw the appropriate view with the indicated views, and it shows the views in the 3D view in figure 1. 1 shows the third angle projection. Look where the angle is pointing in the object, and then they show the drawing operation indicating positions. Defining symbol of the angle projection, show the third angle projection, and then the circle axis to the right and circle axis to the left should be third angle projection. Should be shown in the title block of the drawing. Important to order you for this book and essential read the book. Section 2, first angle projection, you throughout this book. 2. How to use this book. Publisher summary. It applied geometrical tolerance over the technical drawing of the top surface of the must be kept parallel on the axis of the diameter hole 5 hole, which will be the datum axis. Chapter illustrates the diagram required with applying geometrical tolerance, how parallel geometrical tolerance is selected, how the surface of the datum axis is selected with the parallel choices. Chapter also presented the diagram to explain the tolerance frame of the datum symbol, the selected tolerance. If this book was created with the explanation of geometrical tolerance with a desktop reference for anybody involved creating, reading, and technical drawings. If you create the technical drawings in A below, if the reading technical drawings in B below, page 10. Alright, if you're creating technical drawings, you have to create with the technical drawing. Now have to be applied geometrical tolerance for the side of the top of the surface. It must be parallel to the axis 0.5 hole, which is the datum axis. Figure 2.1 shows this shown in the drawing, and then shows when required, surface is required to be parallel into the datum axis, datum line. Step 1, refer to visual. Step index, parallelism, geometrical tolerance. And step 2, second text example, serve the datum from the parallelism choices. Step 3, read the reference page number to the next. Step 4, read the page explanation, select the tolerance, how to apply it to your drawing. Step 5, select the amount of tolerance required for the tolerance frame, either with accompanying strand with a guide you the table 18.3, page 63. An example of the geometric tolerance value, normal precision, mechanical engineering. Angularity symbol is an angle symbol, is 0.2 up to 10, 0.6 10 to 30. Characteristics: a quarter at 30 to 100, an eighth at 8 tenths at 1 to 302, 300 to 1002. Angularity 2. Circular runout, and it shows the ray symbol 0505050505. All characteristics as from talents, normal precision value. Coaxiality is a concentric circle, and a coaxial 0505, and concentricity characteristic. Also has a flatness, a cylindrical flatness, parallelism, perpendicular position, profile of a line, profile of a surface, roundness, straightness, total runout, characteristic symbol, and symmetry. Apply geometrical tolerance datum reference to your drawing, and then figure 2, 3, and 4. Step 1, look at geometrical tolerance symbol. Look at the geometric tolerance characteristic. Give the tolerance symbol 4-1 in the example of the parallelism. Table 1, geometrical 4-1 geometrical characteristic symbols, section 3. Refer to section 21 of the visual index, page 173, 193. Parallelism, general tolerance of the width, the same characteristics shown with the drawing that you're reading surface to the datum access. Step 4, read the reference page number to the next. Step 5, read the page explanation you select for the tolerance. Step 6, for explanation of the datum symbol, refer to page 28 and 20 through 32. For explanation, tolerance frame, page 23 through 27. 3. Single features, publisher summary. The chapter presents the diagram single features such as axis, cylindrical, surface, edge that could be the components. Some of the example, the combination, and single feature for the illustrated with this chapter. Following sketches illustrate with a single feature that could be the component and shows the edge, surface hubs, cylindrical surface, light on surface, cylindrical surface over the bore on face, medium plane, and axis. Common single feature in following sketches: edge combination, single feature that could be component 1, groove 2, A, slot, A, tongue. 4. Symbol. The publisher symbol. The chapter provides geometrical symbol. The cylindrical with the flatness profile of the line, profile surface of the roundness, circularity. Chapter also provides a description and option along with a solid drawing and geometrical tolerance. Shows features, single features not related, form, cylindrical flatness, profile, polish, profile surface, roundness, straightness, and show the symbols and page. For related features related to datum, orientation, also called attitude, angularity, parallelism, perpendicular, profile of line, profile of surface related to the datum, location, concentric, coaxial, profile line, profile surface position, and symmetry, and related to the datum runout, also called composite, circle runout, and total runout. Alright, symbol drawing, tolerance frame, also known as the feature control frame, show for the multiple tolerance features, a tolerance feature indicator, datum indicator, tolerance axis and median plane, symbol of the drawing, datum axis, median plane, tolerance surface of the generator line, datum surface of the generator line, tolerance feature indicated, and then symbols of the geometric tolerance shows the symbol, datum target, symbol of drawing, datum target point, symbol of drawing of the datum target line, front view, symbol of the drawing, datum target line, side view, datum target area, diameter 4, geometrical symbols, TED, theoretically exact dimension, sometimes called true or box dimension, projected tolerance zone, and maximum material requirement, least material requirement, envelope requirement for state condition, averages, part, common zone, minor diameter, moisture diameter, pitch diameter, line element, non-convex, any cross section. Table 4, 6 other symbols throughout this book, diameter, radius, and all-around profile, and a sphere diameter. Tolerance frame, publisher summary. The chapter provides various forms of the geometrical tolerance, rectangular frame, illustrates frame with the datum and the datum, and with the datum with the maximum material requirement applicable to the tolerance and multiple datum references. This chapter also presents frames to specify the forms of the feature of the tolerance zone to specify the elliptical tolerance zone to specify more than one tolerance frame and one feature. Without datum, it shows the symbol for the drawing interpretation, and with datum symbol for the interpretation, and then a symbol for the drawing interpretation, multiple datum surfaces. Symbol of the drawing interpretation, maximum material requirement, applicable feature, maximum material requirement, applicable datum reference, maximum material requirement, applicable both tolerance and datum reference, maximum material requirement, a tolerance in more than one datum reference, and when the tolerance is restricted to the length of the feature, and then it shows when the tolerance is restricted while the feature of the length of the feature, maximum material requirement applicable to the tolerance more than one datum reference sequence. Either datum is not important. When tolerance appears, apply to the more than one feature to specify the form of the feature tolerance zone. Specify the tolerance, elliptical tolerance zone, more than one tolerance, one feature, more than one feature of the line instead of surface, single zone. Applying several separate features, common zone, profile characteristics, applying entire outline cross section. Profile characteristics, applying the entire surface. Alright, datum symbol. For the chapter provided with a diagram with the datum symbol for the because of the tolerance rough feature for the relay with the datum letter shown with the tolerance frame of the chapter residence. A location for the datum triangle when it's on line with what's on plane with the frame tolerance feature for the datum with the same with the datum letter with the datum letter also provided in this chapter. When tolerance feature of the datum letter is shown with the tolerance of the datum is represented with the drawing in the following way. Show these datum letter frame connection line datum triangle can also be unfilled. Location datum triangle. The location datum triangle is represented with the following ways. Symbol of the drawing interpretation, plane or line. Datum is a plane or a line. When datum is an axis, when the datum is a median plane, when the information space with the two dimensions arrowhead, when the datum is applied with the restricted part of the feature. When two maximum when datum is a restricted feature, when two datum features combine with one single datum reference. When datum is for the drawing plane, when the datum and one common axis or plane form into two different features, datum is one common axis or plane. When datum is without a datum letter, when the datum is without a datum letter, when the tolerance feature and the datum are the same. 7. Datum target. The publisher some of the chapters describe it as datum target as a point area with a workpiece for the datum target, the place for the contact with the support with a weak plate, workpiece for the manufacturing inspection requirement of the part with the irregular contact with the datum target could be required. The chapter provides the datum diagrams to explain the 3D plane diagram system as well. Sometimes even the additional relationship of the three-plane datum system is required. Datum target is either the point of the line area workpiece. Datum target is to be placed over the contact with the support of the workpiece manufacturing and inspection equipment. When part of the irregular contour casting, forging, sheet metal parts, etc., the use of the datum target could be required. Example 1 is interpretation of the datum target, and then the datum type of the datum target. Type of datum target, the three-plane datum system, normally orientation tolerance with one or two datum or division, sometimes where the use of the positional relationship of three-plane datum in the system is required a three-plane datum. All the planes are perpendicular to each other. Three-plane datum systems of the secondary datum plane, third tertiary datum plane, primary datum plane, as shown in the drawing. Another example, three-plane datum system as used for the datum target. For the datum target is either the point or line or area of the workpiece. For the datum target is to be the place for the contact support for the workplace for the manufacturing inspection equipment. Use for the datum target be required when the part of the irregular contour show the example 4 datum targets is shown in the paragraph. Know the datum targets are A1, A1, A2, A, and A3 establish the datum A. Targets D1, B2 establish datum B. The datum target C1 establish datum C. Only datum target information related dimensions are shown in example 4. No other dimensions have been included. 8. Tolerance and features. Publisher summary. The chapter reviews the illustration of the tolerance frame and the tolerance feature for the chapter provided by the diagram, tolerance feature for the outline, feature for the projection line, and the extent of the dimension line. Tolerance restricted for the feature for the leader line with the arrowhead for the connection for the tolerance frame and the tolerance feature for the tolerance feature is labeled with the following ways. Placed on a line outline, and it shows a symbol in drawing interpretation. Placed on an outline feature. Placed on a projection line. Placed on extended dimension. Placed on extended dimension line. Tolerance restricted part of the feature placed on the reference line, placed on the axis, placed on the common axis, placed on common axis. 9. Tolerance zone. The chapter explains what the tolerance zone with a zone with when all the points of the features are contained with the tolerance feature for the form of any form of the orientation left the restricted. The chapter allows to describe various forms of the tolerance zone with the diagram as a geometrical tolerance deference for the assuming that the tolerance zone with is always normal to the surface unless otherwise indicated by the tolerance zone is all the points of the features contained. Figure 9.11. The tolerance feature for the any form orientation zone is restricted to 9.2. Alright, the various forms of tolerance shown in the table. 9.1. Tolerance zone shows the inside of a circle is a circle between two concentric circles, a circle inside a circle between two equidistant lines or between two parallel lines. Two parallel lines inside a sphere, a circle with a gleam on it, inside a cylinder in between two coaxial cylinder with hidden lines through it, between two parallel lines or between two equal surfaces. Shows the surface over a surface inside parallel is a rectangular prism. Inside a parallel pipe, the equivalent of space between the horizontal plane with the two vertical planes, and shows the horizontal vertical plane, horizontal plane, tolerance zone direction, width of the normal for the surface of example 1, unless otherwise indicated example 2 below. Tolerance zone with a normal surface. Tolerance zone with a specified angle surface. If the angle is example of the 2 above was 90 degrees instead of 50 degrees, as shown in the figure 9.3, it will still be shown with the drawing not the same as for the normal surface. And the example of 1, in example of 1, 90 degree angle file with the contour of the surface. Example 2, the angle is always fixed with the relationship of the axis. Same tolerance value, more than one feature. So restricted tolerance, common tolerance zone. Common tolerance zone, same tolerance value with more than one feature. 10. Theoretical exact dimension. For the publisher, some of the review of the theoretical exact dimension of the rectangular frame. Theoretical exact dimension may only vary where geometrical tolerance is stated with the tolerance frame and associated with them. They should be given the dimension of the theoretical exact location. Features for the tolerance of the angular position of the profile of the line profile of the surface. Theoretical exact dimension is so even the true box dimension must be dimensions are shown rectangular frame. Theoretical exact dimension may only vary with the geometrical tolerance stated with the tolerance frame associated with them. Theoretical exact dimension should be even the dimensioning of the theoretical exact location feature for the angularity position, profile of the line, and profile of the surface. Use theoretical exact dimensions. 11. Projected tolerance zone. But the publisher summary of the case for the tolerance is oriented for the angularity position, and the tolerance can also apply with external projection, or if not to the tolerance itself. And for the projection tolerance zone, with a chapter presented with a diagram to explain with the projected tolerance zone with no object, no projected tolerance zone with a projected and with a projected tolerance zone. Projected tolerance zone is a symbol P. Within the case of the tolerance orientation, angularity position for the tolerance with applied with external projection of it or not of the tolerance itself. With the answer for this is the projected tolerance zone. Explanation of the projected tolerance zone. No projected tolerance zone with projected tolerance zone. Alright, 12. Maximum material condition of the publisher summary. Chapter review of the maximum material condition. The chapter illustrates for the maximum material condition. Shaft of the maximum material condition would be the diameter everywhere over the maximum side with the whole of the maximum material condition. When the diameter is everywhere over the minimum side with the chapter defined with the maximum material condition principle, the exact measured diameter of the pin depicts total increase of the straightness of the tolerance actual pin of 20 with the allowed straightness of the 0.10. But actual pin is 19.96 with all allowed straight tolerance increase of the 0.14. Applies all other side of the 1996 to the 2020. or just 20. The maximum internal material condition for the component with the feature for the component with the maximum amount of the material. Example 1. The shaft of the maximum material condition would be the diameter is everywhere with the maximum size. For a hole, the maximum material condition of the diameter is everywhere with the minimum, as is a minimum size. Symbol can be played for the tolerance frame in the following way: with the tolerance zone, after the datum letter, after the tolerance zone, with after the datum letter. Maximum material principle. The material principle applies only with the feature axis of the median plane with the axis measure for the diameter over the pin with the figure 12.1 to pick for the total increase of the rates from the tolerance. Actual pin over the diameter 20 allows straightness tolerance of the 0.10, but if the actual pin is to the diameter of 19.96 allows straightness tolerance of the 0.14. With the supply of the L, the other shift with the diameter of 19.96 with the 20. This straightness tolerance is allowed to the increase of the 1/10 of the maximum 14, depending on the actual measured size of the pin. Table 12. Maximum material condition related definitions. MMC, the state of the feature for the everywhere of the maximum material size. MMS, limited with the size of the material feature for the shaft of the maximum limited size, whole maximum limited size. Maximum material virtual size. MMVS, the maximum material size, plus or minus geometrical tolerance for shaft. The MMVS equals MMS plus geometrical tolerance for a hole. And then in the box, the MMVS equals the MMS minus geometrical tolerance. Maximum material requirement. MMR is required by the drawing, indicated by the drawing, placing the symbol M in a box, a circle, in the tolerance frame, E with the geometrical time with the datum letter, both. Table 12.2, the example applying maximum material principle. Maximum material size, actual diameter of the measured pin, plus the maximum straightness tolerance are allowed. If the pin is the diameter of 19.97 of the maximum straight tolerance of 0.13, thus making the maximum material virtual size 20.1 diameter. Pin measure for the 19.99 maximum straightness tolerance allowed is 0.1111, making the maximum material virtual size 21.1 diameter. Maximum material principle applied. Datum feature. The principle of the datum max for the datum median plane to the float relative to the tolerance feature. Further, in addition, with the stated tolerance for the feature frame can be achieved with the maximum material requirement for datum. Shows example. Total concentricity equals concentricity total n in total multiple material condition of 0.30. Any tolerance below multiple material condition of 0.9. And then that continues. Max material condition at a perfect form of the condition when any of the errors required by the team and the max material limited side of the part of the upper limited side of the assumed that the part is perfect form of the pin with the figure 12.2 for the max material condition is the diameter 12 of the pin must be perfectly straight. When the pin is the lowest size with a diameter 11.95, the straightness tolerance can be 0.5. If the point to any dimension of the diameter 12 and the diameter 11.95, the straightness tolerance is adjusted accordingly to the diameter 11.97 of the pyramided straightness tolerance of the 0.03. Alright, least material condition published for some of the least material conditions described with exactly the condition on the feature of the side of the least of the amount of the material of the side of the limit of the chapter explained with the least material condition with the minimum diameter with the whole the least material condition of the maximum diameter least material principle allowed with the datum axis the datum median plane with the float relative to the tolerance feature for the having least for the material condition. Approaching maximum material condition chapter illustrates the minimum of the thickness of the 5 mm of the tube of the tube of the piece of the manufactured either least material side of the maximum material size, least material condition with the condition with the feature side of the least material amount of material within the size limited for the shaft of the maximum and minimum diameter for the whole of the maximum diameter limited material condition. Read the alternative maximum material condition if the condition opposite of the maximum material condition. For inner shaft, the least material condition would be with the diameter everywhere to the minimum size. For the whole least material condition for the diameter everywhere with the maximum size. The L in a circle can be played with the tolerance frame of the following way with the tolerance value of the datum letter and the tolerance value asked for the datum letter. Show the definition, least material condition, LMC, with the shape of the feature of the features available, the minimum material, least material size, MLS. Limited size of the material feature of the minimum shaft of the maximum limited size of the whole, maximum limited size of the least material of the minimum material size plus for the minimum minus geometrical times, virtual size MLVS for shaft of the limited material virtual size is equal to limited least material size equal minus geometrical tolerancing, and then for a whole least material visual virtual size is equal to the least material size plus geometrical times least material requirement LMR. LMR is required for the drawing, indicated by the drawing, placed with the symbol L. Tolerance frame either the geometrical times after the datum letter or both. Least material principles allow for the datum max for the datum medium plane for the flow of the relative of the tolerance frame of the least living thing in the material condition approaching the maximum material condition. The shift of the datum, the form feature must not violate the least material virtual condition, geometrical ideal form, least material's virtual size. Figure 13.2, for no example of Figure 13.1, the minimum thickness over the 5 mm of the tube can be achieved with the piece over the manufacturer for either the least of the material or size or the maximum material size. Figure 13.1, example of applying least material principle. 14. Envelope requirement. Publisher of the chapter explain with the envelope requirement of the represent with an encircle with the OEE. With the symbol OEE specify with the cylindrical surface a single feature with the side with a feature with the two parallel opposite plane surface with a maximum material side that must be with imaginary envelope with the perfect form of the chapter illustrated with an envelope requirement with a form tolerance of 0M feature frame the envelope requirement with a symbol over the end place over the size tolerance applicable to the individual dimension. The envelope requirement with the present the symbol of the E in a circle that specified with a cylindrical feature for the single feature size or feature for the two parallel opposite planes for the one end and maximum material size must be with the imaginary envelope in a perfect form. Envelope requirement must be indicated with the form of the tolerance for the 0 and M for the medium feature for the figure 14.2 with the envelope requirement symbol of the E circle with a place for the size tolerance of applicable to the individual dimension. Figure 14.1 shows example environmental envelope requirements and Alright, figure 15, free state condition, and the publisher sum of the chapter provides the end of the tolerance and non-rigid, flexible for the part of the ISO 1057-9, with the provided the sum of the principal condition for the drawing with the non-rigid part of the ISO 1057-9 is played with the drawing with all the geometrical tolerances but do not have the symbol of the 00E, OOE, tolerance frame and apply with the restraint with the assembled condition for the ensure the non-rigid part with the correct with the dimension with the assembled and function. Some of the tolerances apart with the while with the restraint with the restraint will represent with the restraining forces when assembled with an in function. When a part of the free state with addition is unassembled, the condition the external force of the missing shape of the part with some example of the non-rigid part with the rubber parts as with the O-ring, plastic parts for the thin plastic sheet for the thin wall parts for the thin cylinder for the non-rigid part with a certain dimension for the assembled, but will adopt the other dimension for the free shape of the ensure for the non-rigid part with the correct dimension with the assemble the function with the sum of the tolerance of the part will apply to the restraint. If the restraint it will be represented with the restraining forces on the part of assemble the function. Some geometrical tolerances will apply with only with the free state with the done with the placing of the symbol of F in the circle with the symbol of the tolerance for the tolerance frame, i.e., and then when ISO and then 57.9 INR is not in the drawing with the geometrical tolerance, but do not have the symbol 0 F in the circle with the tolerance for the apply with the restraint assembled condition with the drawing of the non-rigid frame shall include the following. The ISO 1057-9 NR with the indicator of the drawing with the near the tile block. The symbol should be placed. The F symbol should be placed with the tolerance frame with the geometrical tolerances. Geometrical variation allowed with the free state with the condition with the free state tolerance applied should be displayed with the drawing example of the direction, gravity, orientation of the part, i.e. when the part is horizontal position, and this condition of the part should be restrained and meet the drawing requirements. An example shown with the tolerance non-rigid flexibility part according to the ISO 1057-9. Give an example of 1 with the tolerance for the non-rigid flexibility part ISO 1057-9. Note the dimension of the diameter of 200, for example, 1 minus 0 over the 1. Example of 1 above the indicated average size. The calculator taking the average of at least 4 measurements. Alright, Chapter 16, Screw Threads and Gears and Splines. Publisher summary with the geometrical time with the datum reference with the apply with the screw thread with the tolerance datum and with the apply with the axis for the thread derived with the pitch cylinder with the left side of the white state with the chapter illustrated with the diagram with the geometrical tolerance applied with the screw thread. Datum applied with the screw thread with the geometrical tolerance applied with the gear with the geometrical tolerance with the datum with the reference with the applied with the screw thread with the tolerance datum is applied with the axis for the 3 thread derived with a pitch cylinder unless the otherwise state with a geometrical tolerance applied with a spline with a gear, specific feature applied with a pitch with a diameter PD with a major diameter MD and a minor and a least diameter LD must be stated beneath the tolerance frame and beneath the adjacent datum frame. Example 1, geometrical tolerance applied with a screw thread. Datum 2, applied with a screw thread. Example 3, geometrical tolerance applied to gear. Datum applied to a gear. 17. Principles of independency. Principles published or summary of the chapter defined by the principle of the interdependence of the geometrical tolerance of the chapter presented with the requirement of the tolerance for the ISO 8015. Diagram geometrical tolerance independent left of the particular relation for the specified by the drawing. Principle of the interdependency applied with the international standard ISO standards, but when using American National Standard Institute or ANSI. Principle is independent of the meaning of each of the requirement of the dimension for the numerical tolerance specified by the drawing shall meet independently unless for the particular relation for the specified by the i.e. the maximum material requirement, or least material requirement, or envelope requirement. If for the principle interdependency applied with it must be stated with the title block with the drawing as filed with the tolerance ISO 8015. And 18. General tolerances. Published summary. The chapter describes the general tolerance for the customer, for the workshop, for the caring, for the terms of the workshop. Can be obtained with the tolerance could be done, say with the dimension on with the drawing with the general tolerance applied with the dimension within the chapter that describes the angular dimension that does not have an individual tolerance. The angular dimension should be classed as the general angular dimension through the general angular tolerance with applied with the least dimension. General tolerance for the tolerance or customary workshop with the accuracy with the tolerance for the workshop can easily obtain with the tolerance could not stay with the dimension on the drawing. Geometrical tolerance is applied with the dimension, and each workshop has its own standard general tolerance if that it works. It will have the geometrical general tolerance of the linear dimensions. 8 will have the general tolerances for geometrical tensions able to 8.2. Example of geometrical tolerance with the linear dimension, the orbital precision mechanical engineering firm. Show the deviation normal side of the range of the dimension of the tolerances. Characteristics, circularity, run out, all the characteristics. General tolerance for the drawing must be stated with the title of the drawing with an example of the would-be general tolerance for the drawing with the ISO 2668M. The general tolerance for the note of the workshop with the dimension for the drawing does not have the tolerance applied with the workshop will automatically apply with the general tolerance for the dimension as known with the tolerance limits before machining the part. There are also general tolerance for the geometrical strain with the geometrical tolerance as shown by the drawing. General geometrical tolerance will apply. See with the figure 18.4 with the shape of the title block drawing as example would be. Geometrical tolerance according with the ISO 2768K, with note for the general tolerance applied with page 658 with the drawing with the values visibly shown with the drawing with a better geometrical tolerance with the need with a higher general value with the geometrical tolerance must be quoted on the drawing in the tolerance frame. Sample the geometrical tolerance value with the not general values given in table 813. Angular dimensions. Any angular dimensions do not have an individual tolerance for the i.e. angle that should be classified with the general angular dimension, and therefore general angular tolerance will be applied with each dimension. General tolerance for the angular dimension usually specified with the angular units, not in linear units. Example, the general tolerance angular dimension, non-precision mechanical engineering firm. General tolerance for the angular dimension must be stated in the title block ISO 2768. General tolerance following with the note should be in with the title block of the drawing. General tolerance according with the ISO 2768M, with the note cover the general tolerance, but both for the linear and angular dimension for the tolerance of classification for the M, with the medium class, M for medium class for the no ISO 2768 with the linear angular dimension for the tolerance fine F, medium M, coarse C, any very coarse V. Alright, 19, geometrical tolerance. Example of the tolerance value of the tolerance frame. Example of section 19, non-stated value. Thoroughly example, explanation, tolerance value to the proof of the total zone throughout the section 19. Alright, this has been a quick look at the geometrical tolerance test reference.